Hi, sixth grade. This week we're going to do lesson 3 of populations and communities for our notes. So you'll need to share those with me by Friday. And you're going to have a food web assignment. And then, of course, you need to finish up the lab from page 319 last week. So get your notes out and let's get started. If you remember right, we are in Chapter 9, Populations and Communities. In Lesson 1, we talked about the levels of organization, from individual to population to community, ecosystem, and then biosphere. And in Lesson 2, we talked about how populations change from animals immigrating and immigrating in and out of an area. We have natural disasters and diseases that can sweep through and lower a population. Or we have a really good resource, unlimited resources that can cause a population to really soar in number. In this lesson, Lesson 3, we are going to focus on communities, not so much populations, but communities and energy in and out of a community. So we're going to start off with 2 vocabulary words that you're going to need, which are habitat and niche. A habitat is basically the place where within an ecosystem where an organism lives and has its needs provided for. So you can see the habitat there of the elephants in the plains of Africa and the sea turtle in its habitat of marine oceans, and usually warmer. A niche is what a species does to survive in its habitat. And you might have heard of this term before in reference to humans, like, oh, she found her niche in the online world. It means she's found a place where she is surviving and thriving. And animals can do that too. They find a niche, a place where they are finding all their needs are being well met, and they are able to survive well there. For instance, this bee has plenty of flowers, swimming or can fly back and forth to, has wings to do that, and has long tongues to get the nectar out. So this bee species has ways to survive in the niche of a field of flowers. Now, the main focus of this week is this section that we're about to embark on right now. Section C, Energy Flow in Communities. And so pay close attention because this is what your homework assignment is all about when we get into the food webs. And there are big 3 players, big 3 characters in a food web. There are producers, and those are organisms that are able to make their own food via photosynthesis. This is AKA your plants. They are able to just go sit out in the sun and make their own food. And without plants, everything else would be gone because we have to have a base of our energy. We have to have something in our world that can make its own food, and then the rest of us can benefit from that. So then you have consumers that eat. We as humans can't go sit out in the sun and get full, right? We have to eat our food. We have to eat meat, or we eat the plants that make their own food. We'll eat cauliflower and broccoli, which have the ability to make their own food. But if we didn't have those producers that make their own food, what would we eat? We wouldn't have cauliflower and broccoli and lettuce to eat. But we also wouldn't have cows to eat because cows eat plants. So plants are at the bottom of every food chain, and without them, the rest of us would be non-existent. And decomposers play a very important role to plants and us because they break down dead animals and plants, and then they return the nutrients back to the soil. So decomposers, although we don't directly eat them or plants don't directly eat them, they play a vital role in the communities because they are returning nutrients to the soil so our plants can survive. And we just discussed how much we need plants. Food chains. So now we're going to talk about 3 different ways that we show energy flow within communities. All you need to do is write number 4, food chain, and then go to Google Images and find a picture of a food chain for your notes. And I want you to observe, this is where kids will mess up in their homework assignment. And that is how arrows are placed when you have to make your own food web. If you look here, arrows move in the direction of energy. I don't say grasshoppers eat plants, frogs eat grasshoppers. No, that would be the wrong way for arrows to go. Instead, I don't say eats, to help me keep my arrow straight, I say gives energy to. So I'll say grass gives energy to grasshoppers. Grasshoppers give energy to frogs. Frogs give energy to snake. And so the arrows show the direction of energy in an environment. So here we see, up here at this food chain, that you've got several different directions. Okay, you've got the plant giving energy to, oh, what is that? I don't know, a rat maybe? And then that gives energy to the snake, and the snake gives energy to the hawk. But then down here, all those things give energy to the decomposers. How? Well, when they die, the decomposers break down their nutrients and return them to the soil, and then the decomposers give energy to the producers through the nutrients in the soil. So get a good picture of a food chain and add it to your notes. The next image you're going to need is for number 5, a food web. And you can see this is a little bit different than a chain. A food web is made up of many chains, food chains, and so it looks a little bit more tangled up. So I'm going to point out several chains within this food web. So let's start down here with the producer, the plant, and it is being eaten by a kangaroo rat. I guess that's what it says. A kangaroo, we'll just call that. And then the kangaroo rat gets eaten by the tarantula, and the tarantula gets eaten by the rattlesnake. And that is a chain within the food web. And you notice that the arrows are still going in the flow of energy. I don't have the rabbit pointing down and eating the plant. Instead, I have the plant giving energy to the rabbit, and the rabbit giving energy to both the hawk. That would be one food chain, or I can say the energy of the rabbit is also given to the snake. And you can see all those arrows are being pointed and directed to the bacteria, but that is after they die and the bacteria breaks down those dead organisms and returns nutrients to the soil. So get you a picture of a good food web and add it to your notes, please. And the last image you're going to need to get for your notes this week is that of an energy pyramid. And it's very close to a food chain or a food web. However, you just put everything in different levels. So here at the base of the pyramid, you can see that we have all of our producers. And we don't just individualize them out with arrows, but we know that those give energy to the next level. And those are your primary consumers, and primary consumers eat plants. They are herbivores. And so you have your rabbits. There are different breeds of rabbits. Your secondary consumers eat meat. They're carnivores. So they don't directly eat plants, but as you can see, if the plants didn't exist, snakes wouldn't have rabbits to eat. But what a pyramid is saying is why it's getting smaller is at each level, less and less energy is passed on to the animal. So as we get up here, you can only usually go about 4 levels, and then there's no more energy to be consumed. So then you have the apex predators at the top. And an apex predator is a predator that does not get hunted by anything else. They usually die of other means. But like your sharks, your great white sharks, there's not too many things that will eat a great white. Or, I'm trying to think, a lion on land. So apex predators have no predators. And they're usually at the very top of the pyramid and at the top of food chains and food webs. Producers are at the bottom. That concludes our notes for today, kids. You can go ahead and share those with me, and this section is worth 5 points, and the notes we take Friday will be worth 5 more, so lesson 3 notes combined will be worth 10. Or you can simply wait till Friday and share your notes with me then. Have a good week and work hard.